It is as the technical program co-chair of VPPC 2014 with my colleague João Pedro Trovao that I have the pleasure to chair this second plenary session. This morning we will have two speakers. The first one is Pedro Silva from EFACEC Electric Mobility Company, which is a world leader in charging solutions for electric vehicles. And the second one will be Maurizio Maggiore from the European Commission. So, firstly, it is my pleasure to welcome Engineer Pedro Silva. He graduated in Electrical and Computers Engineering at the University of Porto. He has also an executive MBA in Business Management, and he has the title of Specialist in Transport by the Portuguese Engineers Order. At the moment, he is Managing Director and also member of the board of EFACEC Electric Mobility. Please, Engineer Pedro Silva.
Thank you. Good morning. Thank you for this invitation. I will try to present the history and what we do in electric mobility to show you what I think can be a good story on the infrastructure activity for electric mobility, which we think is a must for the adoption of electric cars, which I think you have been discussing a lot in these last 2 days. So this is a summary of what I will present. First, the history of EFACEC, why we are where we are now. Some achievements, some solutions that are available for the market today, and some of the areas where we are investing more and pursuing more innovation and evolution on the technology side and on the offer for the market. Okay, just some brief words to start. At EFACEC, we see innovation as a value creation. When there is a change, when there is something that allows you to bring new things for the market, that bring value to the market and help the market to develop, and also that bring value to the company, which I think is very important because it's what this industry today needs. I think we are now passing the phase where it's more academic and pilots and trials, and for the mass adoption of EVs, we believe, I think it's obvious that we need to turn this into business and into real economic activity. So this is one of the cases where we apply this concept, and there is a combination of some facts that led us to where we are now. First of all, an anticipation. So we started to believe that EVs can be an activity with future and that can have good growth. We have an active knowledge management. That means we have a lot of knowledge in the company and with the partners that we work, and a lot of experience in working in this kind of technologies for other purposes, of course. Also the proper time to market, so I think we were able to put the products in the market in time, and you will see some examples where we have been the first ones in the world to introduce certain things. And the concretization of this is that we started in 2008 conducting studies on what could be electric mobility. We have an important asset that is all the knowledge and the know-how that we have in the company, mainly in power electronic systems. And There was a good opportunity in Portugal, which probably some of you know. It was a pilot project that started in 2009 under the big name of MobiE, the brand that was the name of the project, the name of the network, and the name of all the electric mobility program in Portugal. All the combination of this, EFACEC was able to capture this and to be now present in several areas of the world, as you will see. So let's start. Back in 2009, the MobiE project was part of the MobiE project was the build-up of a system, of a pilot network and a management system, and all the way how this system would work and how the model for the market and so on. And this was conducted by a consortium of companies that implemented this pilot project, of which EFACEC was the technology partner. In 2010, so 1 year after this project started, the rollout began. But by that time, we were also the first company outside of Japan to have fast chargers for the Japanese standard that was created, the CHAdeMO Association in 2010, of which we are a founding member. And so we were the first company in Europe to have fast chargers, and that allowed to bring support to some initiatives like the presentation of the Nissan Leaf in Europe that was conducted in Lisbon, in that picture in the middle. Just put my glasses. Okay. In 2011, we started to explore external markets. So you see that from the beginning, we believed that electric mobility was much more than a pilot project in our own country, and we started to explore international markets. So the first international projects in the United States, Turkey, in the United Arab Emirates, in England, and some presence in some very important international events like the COP17 climate conference in South Africa. In 2012, we launched a full electric bus together with a bus manufacturer. At the time was one of the first electric buses to be in the market. We, based on the extensive cooperation with one car manufacturer, in this case Renault, we had the certification for the Renault that it's this Z Red is a specific certification. So we tried always to be on top of the things. In 2013, we introduced in the market for the first time, and for a certain period until I would say mid of this year, we were the only company in the world supplying multi-standard chargers. We introduced the new CCS standard, which I don't know if you are familiar with this, but it's a different fast charging standard from what other car manufacturers were using. We introduced it in the market in 2013. We were again one of the first companies to do it, and we were the single company in the world until mid of 2014 to have a dual standard charger. So this is an example of a charger with, in this case, 3 outputs, because besides this dual standard fast charging, it has also 3-phase AC output that some cars use. And in 2014, we have a complete range of products to serve different applications, from private charging to public charging, different powers, different standards, DC, AC. So you see a complete range, which is again probably one of the most complete ranges in the market today. Okay, what are the main differentiating solutions that we offer for the market in this area? You see here a full range of chargers. You have from 50 kilowatt down to 3.7 kilowatts on AC, DC, single phase, with management or without management, all different flavors for all the different applications. We have a strong bet in DC. We have, of course, we have the AC range, but the AC, you have many companies doing AC. You don't have so many companies doing DC chargers. And so we have a strong bet on DC, where the competition is less, the sophistication is higher, and we have a very, very strong position in the market, and probably we are the number one, or one of the two number ones in the world in DC fast charging. Just for you to understand, probably you know all this, but I will just recapitulate this concept. Practically every car in the market has an onboard converter from AC to DC to charge the batteries. And so most of the electric vehicle supply equipment, that's the official name in the standards for the chargers, what they do is to control the flow of power. So they don't convert anything, they just control the flow. So our equipment that are, of course, in terms of technology, more simple than the other ones. The question is that this onboard converter can be expensive, can have some weight and occupy some space, and so it tends to have a limited power. And this is how we charge the battery. Of course, you can overcome this by having an off-board converter, of course. So you can put more power in the battery and charge it faster. So the concept is very simple. If you put a big converter outside of the car and charge directly the battery. So this is basically the principle of DC charge, and why all charge above a certain power tends to be DC for most of the car manufacturers. There's one car manufacturer that doesn't use this concept, but most of all the others use this concept, which is simple, is that you start with AC for low powers, and somewhere in the middle you change and use DC. Okay, these are examples of other differentiating solutions. The integration with energy storage, the integration with renewables, all these are areas that we work, and that can also minimize the impact of the chargers in the network, and even sometimes help the network, because if we have a stationary storage, it can be used for other purposes than just to charge cars. And we have several projects. This is just an example, but we have other projects that involve the combination of stationary storage with car charging. We also believe in open systems, so our chargers can be integrated in practically any network in the world. If it uses an open standard like OCPP, or if it uses a proprietary standard, doesn't matter, we can implement it. So the way we position in the market is to be completely open on this. Again, this is the differentiating aspect from some of our competitors that impose a certain interface or impose a certain connection to their own cloud. We connect to the management system of our customers. And you have here two examples that work in both ways. On the left, You have our management system that can control chargers from other manufacturers. On the right, you have other management systems. In this case, it's the MOBE, but can be any other management system, where our chargers can integrate using different protocols. This is the most common, and we are doing this all over the world. Again, going back to the multi-standard that I presented before, you have here a simple concept of a DC charger with the CHAdeMO standard. You can identify basically 3 blocks there. You have the power electronics, which is basically something that converts the AC into the voltage and current that the car wants. You have a controller, and you have HMI communications and high-level management. And you have internal communications between all of these blocks. So to have a new standard, what we did was simply to add a second output and a new controller connected to the central controller that we already have. So we can choose, using the same power electronics, to use one or other output. We just use different controllers to implement different interfaces with the vehicle. And we have, of course, an internal communication between these controllers. So for us, it was more or less fast, not only to deliver the new standard, but also to propose the dual standard, which was something that when we proposed this for the first time, nobody believed it was possible, because the standards are so different that we got feedback from many people when we presented this in an exhibition in the United States in 2012. Many people were coming to our stand and saying that you are showing something that is impossible to do. Well, it's possible, and it's working, and it's in the market for more than a year now. And most of our competitors are now coming with this solution also. Of course, this brings an important advantage for the market, as we believe. That is the possibility to have retrofit on existing chargers that were using the first standard. So, for you to have an idea, a CHAdeMO charger costs roughly the same of a CCS charger. So in terms of investment for the network operator or the owner of the charger is more or less the same. The income that you get with, or the revenue that you get with a CHAdeMO charger by charging the cars that are compatible with that standard can be a certain amount per year or per month, doesn't matter. The other cars that are using the CCS standard, which are more brands, can bring also some revenue from that charger. But if you combine both, which is if you go to a CHAdeMO charger and you add the CCS charger to it, you will have both revenues combined with much less investment. So this is a good rationale, and I think we were able to convince many people of this good thing of combining the two standards in a single equipment. And I think it's now completely accepted in the market, and it's even recommended by many people for even the discussion was there for the new CPT directive, where it is stated that you should have CCS in Europe, but it doesn't exclude the other, because you can just combine in the same charger and do not exclude the possibility to charge cars that are not compatible with CCS. So this is an example of a 50 kilowatt charger that is in the market, and we have at the moment around 500 units already working in the field in different continents with the combined standards, multi-standard. Again, an innovation that we developed is to have chargers with the master-slave concept. So you don't need to replicate everything in its chargers. You can have a user interface, you can have communications and database and everything in just one station, and then you have slaves or satellite stations of this charger, which is again a good driver for the rollout of different charging stations in a certain area at a lower cost. So another example of master-slave, another example. Just some examples of combination of different equipment on this master-slave configuration. Okay, so where do we stand and what we think is coming next? This is the situation of the standards that exist today in terms of fast chargers. You have in the United States basically the CCS, or in the United States they call it sometimes the combo or the SAE standard, and you have the CHAdeMO standard, which is this lower round connector. In Europe you also use the two. You have the CCS, but the connector is different because in Europe we can also have three-phase charge. In the United States you don't have that. And you also use the CHAdeMO. So these are our two main markets and where we are more active. And the charges are usually by standard. In China you have a specific standard, the Chinese standard. And in Japan you have AC single phase and you have CHAdeMO. That's what you have there. So this is for you to see how different standards for fast charger are being used in different parts of the world. On the bottom you see some of the brands of the cars that use one or other standard. We have at the moment a penetration of, these are just examples of cars that are compatible with the infrastructure that we provide clients all over the world. But probably the most important for us is the group of partners that we have on the right bottom part of the slide, where we use some of the most prominent companies in different countries as our partners, and that helps us to have this coverage of the world. For you to have an idea, in September we had around 3,000 chargers installed. You see the most of them are in Europe and United States. You have there Asia, but Asia is basically Turkey, so it should be Europe. And some Middle East. In Asia it's basically Turkey and some Middle East, so it's not really Asia. South Africa is a good market for us, especially South Africa. The rest of Africa is not counting. Brazil and the United States. So Europe and the United States have been our main focus up to now, and of which, as I mentioned before, we have passed the 500 quick chargers in September. And again, basically Europe and the United States are our main areas of sale. Again, trying to be always in front and innovative and bring new solutions to the market. We introduced last week at an exhibition in Munich at ICARTEC, we introduced a new model which we believe will help a lot to develop electric mobility, because it's a semi-fast charger, 24 kilowatt unit, which is very simple to install because it's a wall mount device. You don't need any civil construction, you don't need any very expensive installation works. And this is targeted for public or semi-public or even completely private operation with a very simple user interface and with connection to your iPhone directly, so you can control it directly without passing through the network operator, which is the usual that is usually used. And it's very, very compact. It's the smallest quick charger in the market today, and with a very good efficiency and very good technical characteristics. Okay, just finalizing, and this I will, of course, not develop a lot because you will understand why, because we are a company and not exactly an university, so we cannot disclose too much before it's time. But just to give you an idea that this is an area that is still in the very beginnings, although we are here now for 5 years, and I think we have achieved a very strong position in the market worldwide. We consider that we are still in the beginnings, and a lot of evolution is coming, and a lot of things are worth to work and develop on. And I have here some lists, so just to show it to you. So the first one is smart charging. You know what is smart charging? Is to manage the rate and the time where you charge your car. So if everybody starts charging its car at 10 o'clock when the electricity rate is lower, you have a big impact on the network once you have a big fleet of cars, which is not the case today, of course, anyway. But we work in this area of smart charging. We cooperate with some universities, and we have some R&D projects and pilots to be able to manage both from the consumer perspective, for example, not to overload the contracted power that you have in your home, just management done by the charger in communication with the smart meter, but also managed by upper levels like the network management system that can control the rate of the charge and adapt it to the needs of the car without compromising the network. Demand management, it's more or less related. That's you need to manage in a certain area or in a certain community the way you charge cars if you have a lot of cars in that area. Solutions for fleets and condominiums. We believe that the adoption of EVs is going to be in the beginning, and it is. In fact, we are seeing that very much driven by fleets, by companies, not by the private user, because it's still an expensive thing, an EV. And you need to offer solutions for this kind of customers, which are not necessarily linked to the network system, like the MOBI in Portugal or some other many networks that you have all over the world now, which are basically targeted for managing the business side. Who can charge, how does it pay, how it accesses the charger, and so on. And we need solutions to manage the power, to manage the local management, and we work a lot in that area also. V2X, you know what V2X is vehicle to grid, vehicle to home, vehicle to load, whatever you want of this. Of course, we have programs also on that area. That is the capability of getting energy from the battery of the car and use it for other purposes. I'm sure you are familiar with all these concepts. Communications EV charger, this is an area that is also having a big evolution today. You know, there are standards coming out. The 15118 is a new standard that has a PLC communication between the car and the charger, which allows for many different things that we can imagine now. In fact, the standard has already some use cases defined, but you can think of many things that you can do about this, from managing up to identification, up to whatever you want of it. New charger models, of course, we just show you. We believe that probably the chargers we are selling today are not the same chargers we'll be selling in 4 or 5 years because of the evolution, different powers. I hope not an evolution on the standards again, but an evolution in powers and capabilities and functionalities. Lower and higher power chargers, this is a very important area for us. You saw that we have chargers that are fast and chargers that are semi-fast and chargers that are slow. And we believe that with the introduction of more battery capacities in the car or batteries that can be charged faster, higher power chargers will be necessary in the future. And we already are working with some car manufacturers on trying chargers at 100 kilowatts or 150 kilowatts to charge bigger batteries, but also to charge faster the existing ones. But also lower power charges. And I think this is a very important aspect. That's why we introduced some models that I showed you. Because many times you don't need to charge your car in 15 minutes or 20 minutes. If you go to a restaurant or to a hotel or to a movie, or if you come to this conference, all you want is to have your car charged when you go away. So 1 hour is more than enough. So a slow charge is not good because probably you want a full charge and you don't want to wait a lot of hours. But also you don't need a fast charge. And the semi-fast is important. And we are working in lower and lower power charges and bridging the gap between what is fast charge and what is slow charge. Of course, payment systems, roaming, integration with different systems. This is ongoing. This is always a matter of work for us. As I told you, we integrate our chargers in many different networks all over the world, and they have different apps, different RFIDs, different NFC phones. They have different roamings between them. They have all these different things. Sometimes we already start introducing payment by credit card directly, so just pass your credit card and use. You don't need to have a contract or identify. So this is an area where I think the marketing will introduce new innovative ways, and we cannot predict the future because I think EVs will be more or less like phones in some years. We hope, at least. Open protocols is, of course, related to the previous. Energy storage, as I mentioned, is also a very important area for us. Energy and traction systems for buses. Electric mobility is not just about cars, it's also about public transport. I passed one there that is very important for us now, also wireless charging. This is an area that we think also can see a strong evolution in the next years. I think we are not that far away, maybe 2 or 3 years before we start seeing cars coming to the market that accept wireless charging. So of course we invest and work a lot in this area also. And basically that's it. Thank you.
Thank you very much for this nice presentation. So we have time for a couple of questions. So please, if you have a question, introduce yourself and ask your question.
Good morning. I'm Ganem Putros from Northumbria University in Newcastle. Thanks for an interesting presentation. My question is, there is some evidence that fast charging might be harmful to the battery, especially if it is done on a regular basis. What's your view on this, and do your fast chargers have any mechanism in them to protect the battery?
Okay, this is a very common, very frequent question. first of all, we don't manufacture batteries, of course. So we have to adapt to what the batteries that are in the cars can accept and how they are managed inside of the car. You know that fast charging is just the possibility to put a bigger power in the battery, but the battery management system that's inside of the car must manage this. Having said this, how does it work? I don't know how familiar you are with fast charging, but usually there is a negotiation of the power between the charger and the car. The car says how much power it can accept, and the charger says how much power it can give, and they negotiate, and they are always keeping this process during the entire process of the charging. So if the car asks 100 kilowatt and if the charger can give, it will give. So that management should be inside of the car. What happens is that the cars manage not to overstress the battery. When we are talking of fast charge, we have to understand what is fast. With most of the batteries that are equipping most of the cars today, that is at a rate of 2C. That means 2 times the capacity. That means if you have a 24 kilowatt hour battery, like you have in many cars, you shouldn't charge above 48, 50 kilowatt. I believe that this rate is not harmful for most of the battery technologies that you see in the market, which say they can accept even more. So the car manufacturers are a little bit conservative on this. They don't go above 2C. And also they are tracking about the balance between the cells in terms of voltage, and they are watching the temperature of the battery. Those are the 2 parameters that most adversely can bring a battery life down, is overcharging and temperature. And so this is always managed during the process, not to overheat the battery or not to overcharge a single cell. What I believe is that at the moment, people are a little conservative on this. And I think that probably the existing batteries could be charged faster, but they don't go above that for, you know, it's still not, they don't still have enough experience, and they need to have a warranty on the battery and so on. So I think all the industry is a little bit conservative at the moment, and I wouldn't be surprised if in some years, in the next years, we will see the charging rates to go up. I wouldn't be surprised by that.
Thank you. Another question? Sisi?
Yes, I think I just would like to comment. I think this is a very good question and frequently asked in men, and your answer also very good. So my comment is we should look at, as my keynote speaks, we must look at the holistic approach, the overall system, just that nitty-gritty things. So we have to look at the whole systems, what kind of battery you use, what kind of vehicle you use, and what is the operations of the vehicles, and what is the status of your grid. All this have to take into account, and not just a single answer. For instance, in my experience, if you use LTO battery, lithium titanate battery, because lithium titanate battery can be quick charge. Why? Because there are no CEI layers. It can be quick charge, it can be a long life, 10 times, because in fact it is between the battery and capacitor. However, the energy density is lower, and then it's most suitable for bus and not so distance. And that is a successful example in China, in the Chongqing city, in the public transportation called Hengtong. It has been operated for 2 years, quick charge. The side effect, first, of course, has it impact to the battery life? What is the cost? The initial cost is higher because quick charge you need a big current, big cable So the installment cost is higher. But the time is short, more efficient, and the land use also less, because it is, as compared with quick charge, you no need so many. So overall, in the experience of the Heng Tong, if you for public transportations, if your line is not so long, quick charge is better than slow charge. So you cannot just single pinpoint, quick charge is better or slow charge is better. But in general, of course, slow charge is better. So in my mind, if possible, you use a slow charge. Then recently, opportunity charging 20 kilowatt is very hot, because quick charge is so expensive. But 20 kilowatt just optimum for 2 hours. So I investigate some of the dealer, they sold 20 kilowatt, very good sales. So in general, quick charge only is suitable for emergency purpose. Like go to clinics for emergency, you need a quick charge. This in general, but not in general, but this only in general. But in some certain application, for instance in Heng Tong, in Chongqing, there's quick charge very successful. Land use is small, cost is effective. That is my comment. So on one word, we must open mind and holistic approach. Okay. Okay.
Thank you, Sisi.
Can I just add something, which of course is totally correct, and thank you for this. And thank you for mentioning these titanate batteries. Titanate batteries are one example of a battery that can be charged even faster than what I described. And 10C is common, or even more. So that means if you charge at 10C, theoretically you are at around 6 minutes to make a full charge. So 1/10 of an hour. And what we see is a big interest now, and that's why I also mentioned we are working in systems for buses and things like that, is that, for example, for a bus that operates all day, which needs a very, very big battery, and you have examples of, in China, bus manufacturers with very, very big batteries, as you know. And we believe that it's more cost effective to have a smaller... Exactly. Yeah. To have a smaller battery made of a technology that can be charged very fast and charge it along the way. In certain specific stops, for example, you can charge it, and we see examples at 450 kilowatt or 500 kilowatt charge for a small period of time, and giving enough capacity to drive some more kilometers, and then you do this process again. And you only do a slower charge when the bus stops at night in the depot. This is very, very effective because you bring the size and the cost of the battery so low. Of course, you cannot use any battery for this. You have to use a battery that is able to accept this.
Okay, thank you. Sorry, thank you. I think we can go to the next speaker. Thank you again. Thank you. So the second speaker will be Maurizio Maggiore from the European Commission. He earned a degree in aerospace engineering at Milan Polytechnic in 1985. Then he joined different companies where he mainly managed EU-funded cooperative research projects. He joined the European Commission in 2002, and in the past, Maurizio Maggiore has been responsible for automotive and maritime projects dealing with conventional powertrains and electric drives, and now it is Directorate General for Research and Technology Development for Surface Transport Unit. I think it's okay. So, Maurizio, please.
Thank you for the introduction. Good morning, and thank you for the invitation. I will talk a little bit of different things, a little bit of the motivation for the Commission to be interested in this kind of technologies. At the same time, a little bit of the past experiences that we have had in these domains, And also a little bit, not so much because there's not a big call coming on future opportunities for research. And also, if you don't mind, also some, let's say, outsider views and comments in some areas that just being in a central position, I come to meet here and there. So first of all, is why we are interested in electric or electrified, I think it's better to use this term, vehicles. It's basically an opportunity for solving several problems in one go. It's basically an issue of sustainability. We have the pollution problem, we have the CO2 problem, we have the problem of energy independence that is so clear now with the problems we are having around the world. And at the same time is an opportunity or a threat, depending on how you go about it, for important industries like the automotive and the electronics industry. So we have to take into account all these things and take into account reality, because I think sometimes, I am an engineer, but sometimes we have the possibility of losing track of what's going on. So reality in pollution, for instance. We have, this is a map of 2011, but it's slowly improving, but I think it's not changed a lot. And we see that we have tried to have stricter standards, we have introduced particle number standards and so on, but still we have proof which are coming from many tests and so on, that the vehicles are emitting much more than they are supposed to, and that they do on the test bench when they are certified. So, for sure, we have to introduce real driving testing to make sure that we cover as much of the engine map. At the same time, we have global warming issues, and also there we are trying to put regulation in CO2, and also there we see that there are discrepancies between what is, you see, the difference is increasing with time. And this has been discussed in the press for a long time. These are just a few clips from several magazines. But basically, the answer was, okay, yeah, because people are driving different. Yes, that's true. We've had also some scientific tests showing this, that the people are driving in many different ways. But for sure, the differences are getting worse. So the problem is, for the industry, that the consumers are starting to react. So we have class actions. This one has been recently launched, so I don't know how many are aware that one has been launched in Europe, while in the US and Canada, this has already taken place and they won. So these issues, these discrepancies will have to be taken into account. And then we have oil. Oil at the moment is going down because of the crisis, because of certain things. But for sure, this graph on the right shows that the oil that we are using today is dirtier and will be in the future dirtier because the easy oil is already being used. So when we do, for instance, the CO2 calculation, I've seen these papers on some issues, and I see standard numbers used, which are not realistic. Oil is the oil of tar sands or the shale oil that is so successful in the US takes much more energy to be extracted. So the CO2 emitted when you use it is higher. And this probably, the more we go into this enhanced recovery, as they call it, the more the CO2 footprint will be worse. And of course, probably if the consumption goes on, the price will be high because already at the source it's more costly. So I mentioned competitiveness. Yes, we have European manufacturers which are among the leaders. Basically, in Europe, there are manufacturers that have several models, while many other manufacturers just have a flagship model, and that's it. So in a way, we are, I think, ahead on this. Some of this led to expansion in China. So even if we have models for the European market, there are specific models in joint venture in China. So opportunities for the future. But at the same time, we look at the sales, and I hear important people saying, disappointing sales. Yes, I didn't expect anything different, frankly speaking. I mean, this is a change that needs really a change of mind of the customer. Of course, like has been mentioned, is a costly technology to start with, like almost all new technologies, they're costly at the beginning. But in this case, you also have your customer change their way of thinking, of using the vehicle. So to me, it's not a big surprise. And if I look at the trends of hybrids, for instance, which were an easier sell, they were basically, you drive them the same way as you drive any other car. So they didn't require, other than the additional cost, a big change for the customer. Why here you have to think about charging, fast charging, use a strategy, which is something you were not used to think and takes time to accept. So from this point of view, I see this as a more or less normal thing. Of course, we have to work, we have to improve, but again, we have to take into account reality. I see sometimes things that make me think. We know that range is one of the worries of the customer, and I see numbers for range which are not very realistic. So customers that come up and say, oh, actually it doesn't serve me as I wanted because I cannot do the kilometers that are announced. This might be for the same reason of the discrepancies of the fuel consumption. That is, there are these flexibilities which are used in testing, which translate into numbers which then in reality are not achieved or achievable. Now, for a conventional car, you don't care in the end. Yes, you pay more, so as I said, there are class actions for people that are unhappy about that, but in the end, you get to your place. You will have just to refuel earlier. For an electric vehicle, this is a huge difference for the customer. So, for sure, having these numbers give the wrong message to the customers, and I think is not a good policy. Another situation, let's say, is that you have other experiences from real user. The thing on the top is something that I learned yesterday. So I asked my French colleagues if they confirm what a colleague of mine told me. There's been a show on French television showing a guy who has an electric vehicle and tried to go to a certain distance. And he looked on the, of course, the range was less than he expected, so he looked on the smartphone, went for a fast charging or a charging spot, and it didn't work. Then he went to another one, and also it was not available for the public. So the end is that the car is loaded on a truck and brought home. I mean, on national television. This is a very bad message, let's say, for electrification, and in the era of internet or smartphone, I would expect that you have not only where the charger is, but also if it is active, if there is someone already charging, and everything like that. If it's not like that, of course, the experience for the customer will be spoiled. And if something like this gets aired to millions of people, you cannot expect a big success for the vehicles. It is giving really the wrong message. So we have to improve the technology in many areas. Of course, the cars must become really optimized, and we see now coming cars that are really optimized. We have to improve the batteries, of course, but we have also to improve this kind of systems. Another thing which I believe is that we need to give customers alternatives. People are used to choose from a menu of vehicles, giving them different performance and different capabilities. And now you start to see something, for instance, a car where you can buy it with or without a range extender. with two different sizes of batteries, which is what many people want. I've been talking to a fleet user, since we were talking about fleet, who said, I don't like to buy, I know how many kilometers I need for my mission. I have a fleet which is basically working on a scheduled, and I'm forced to buy a battery which is 2 or 3 times the one I need. Of course, I'm forced to pay it and everything. So that's another easy, I would say, maybe I'm simplistic, but way of satisfying the customer better. And then the other solution for the range anxiety is give mobility services and not just cars. And Fiat in the US, BMW, PSA have announced something like this. I mean, you have a car that does a certain number of kilometers for your use of every day. When you need to go farther, we will rent you a car, we will give you a replacement, whatever. That's the other solution. It simplifies things very much rather than complex situations, a system which need a big investment and a lot of time. And then, of course, this is, to me, is signaling that pure EVs are more oriented to urban and suburban use. Now, when we talk about Los Angeles and so on, we in any case have problems with range, or Paris, or big cities, but this kind of environment, and probably until we have this combination of better batteries, faster charging, and let's say a network which is sufficient, PHEVs and extended range vehicles are a good bridge. Another thing, as I mentioned before, there is this reality on the environmental effect. I'm seeing very controversial results, for instance, of LCAs. I've seen a paper saying that electric vehicles were not giving any benefit if you consider the building phase and everything. Then I looked in the paper and I saw that they were using the data from the certification of the car for the conventional one. And then I said, okay, then I understand why. Because you're underestimating 50% of fuel consumption, you are underestimating several times the pollution. Of course, in the end, I would like to see what is the real result of this. And the same for the durability of the battery, because I've seen papers assuming 2 batteries or 3 batteries in the life of the car. Now, of course, if the battery is one of the LCA problems, let's say, and you have to change it twice or 3 times, so how, let's say, how real are these numbers to get something that we can provide to policymakers? Because at the moment, the messages are so contradicting that you can have a choice or another, and you're not sure which is the good one. So all these things, we will need to have reliable data or good sensitivity analysis to get an idea of what it could be, maybe in 5 years or in 10 years, where the electric supply will be evolving towards more renewables and so on and so forth. So, given all this, what are we doing in the European research? We have had, this is a bit of the past now, but we started in 2008-2009 with the Green Cars Initiative, which has been, in my view, a good success. It has really brought together a lot of actors and has been giving opportunity, let's say, to exchange and to have information and to drive, let's say, the process of innovation. This is the result. I mean, Green Cars Initiative finished in the sense of projects launch last year. There are many projects still running, but this is the picture we have. As you can see, we have achieved a very good coverage of all the aspects. The bigger chunks on the right are basically the whole vehicle design, integration, and the bottom one is battery, because of course that's an area where we want to try and catch up. But we have covered a lot of other areas like motors, like management, like auxiliaries, and many other things. And at the same time, from a European point of view, we have involved a lot of member states with the best, let's say, entities and stakeholders they have. I just go quickly through some of the projects that have already finished, not many, but they're coming. So, for instance, this is a small urban vehicle which has several innovations, like, for instance, is designed to be safe. It's an L7 but has been crashed and designed for a crash which is similar to the what you expect from a car and not from the normal L7E, which is very, basically doesn't need any certification. The other point is that this has two axles, like Tesla has just announced. This has been already done and started. Two axles which are basically exactly the same, except that the front one has the steering. And in principle, you could also put the steering one on the back to have better maneuverability. But it's quite efficient, and I think it's a good result to have something that shows the potential. As I said, without making compromises on safety, which is one of the things which make me a little bit nervous when I look at very light vehicles. We are working on motors. So this one, for instance, is a project for in-wheel motor, which is trying with quite high power still to have integrated power electronics and air cooling. We'll see if they manage, but we had the first milestone, and it's quite. It looks quite good. This is the project which is finished and demonstrated that they could achieve with a magnet with 10% the dysprosium of the current technology, let's say, by coating outside and not just having dysprosium dispersed in the whole mass. They achieved a similar performance, or even slightly better, with 10% of dysprosium, which is the most costly rare earth. So this is also a good result. At the same time, they work on the topology and everything, so they optimized the motor for a certain cycle, which was also a real driving cycle and not just an NEDC. This is one of the several projects we have on batteries. Pick it up just because I had some data, but basically we have projects looking at many different approaches which are not for this generation, because this generation I think is gone, for the next one or the one after, trying to give a technological basis for European industry to become competitive and start to produce in Europe. This is another example of 3 or 4 projects which are looking at the auxiliaries. I mean, we are talking about range. I mentioned real driving, but apart from the behavior of the driver and the slopes and whatever, the point is that in many cases you are throwing away 20, 30, 40% of the range, depending on where you live, just to cool or heat or defrost your car. So we have funded several projects trying to reduce the burden that this puts on the battery. The first electric cars basically had a resistor put in the normal circuit, and that was awfully inefficient. These are systems which are trying to find other ways. This is basically a self-contained roof which has solar panels, some battery, and Peltier-based cooler and heater, illumination. All is autonomous, and it could be used in any car, including conventional ones, or a hybrid where when you stop the engine you no longer have, let's say, spare waste energy, and of course for an electric vehicle. Then of course we have looked several projects at making the vehicles lighter. We have outside a composite car. That's a costly approach. Of course, we have projects like this which are trying to reduce the cost. We have other projects trying to have a compromise between cost and materials and production run, because also some materials are giving you good weight reduction, but sometimes you have to either slow production rates or you have to invest a lot in manufacturing facilities. So we are funding several projects to try to get a better compromise. We have several things on trucks. Most are on conventional trucks because fully electric, particularly for long range, is a bit far away. But we have hybridization, for instance, like in this project, which would in any case help in improving the efficiency. And then, just for something completely different, as someone said, this is probably the smallest vehicle that we have funded the project. Sorry. It should be a video, but maybe. Well, anyway, the video was showing how it happens, but it's basically, oh, what? Yeah, several times, but it doesn't start. Anyway, sometimes it takes some time, and then it will start. Basically, this is probably the smallest hybrid vehicle that we've funded. As you see on the right, it's an extended position. You see on the left is folded, is something like this. And the pack you see here is a self-contained hybrid power with battery, with motor, and it's retrofittable. So you can buy the bike without and then put it on, and it becomes a pedelec. To me, this is really something, nothing to compare with the trucks, with the cars and so on, but this just shows what electrification can do. And the graph on the top, you see the red thing is the volume of the folded bike, and the others are the competitors. So you see that is a huge difference. And it's 7.5 kilos. So it's really, I think, demonstrating what innovation can do when you have a good, let's say, technology package with electrification. Then we had many other projects which are run by the Directorate for ICT, DG Connect. So there, I'm sure many of you also have participated in them. I know them a bit superficially because I'm not involved, but they have looked at control, at dynamics, at the electronic architecture. So it's smart grids, it's more IT oriented. I also don't want to forget hydrogen because it's something that is still in the electric arena. I think they share many of the components, so it's a mutual benefit, let's say, what we are doing in the Clean Car Initiative and what they are doing in the JTI. The JTI, the first one, has been completed. They have launched many projects, demonstrators, and so on and so forth. They are looking at the energy production. They are early market introduction for some specific applications. The portfolio of projects running is 127 on all areas. This includes also non-transport. And just to give an example, this is the biggest demonstration of buses which has been taken out. Compared to the first ones, they have reduced fuel consumption. And they are demonstrating in many environments, in many cities, what these buses can do. At the same time, there is the issue of hydrogen production, not only for the greenness of it, but just that, as you can see in the picture, this is a way to have a local hydrogen production without transporting it. It's less efficient on one side, but on the other, it could help establishing the network. Because, of course, all this, like for electric cars, it needs a network. And hydrogen probably needs much more because there's no electricity is available around. You just need to put something in between, while here you have to make it from scratch. Now, for the future, we had the launch of Horizon 2020. We've had an outline of what we are doing, and we for sure will heavily involve into clean propulsion because, as I said, the problems which are there need to be solved, and therefore, on one end, we have decided to put the conventional vehicles into the normal calls, so to say. So we will have, we've just had actually a first call with the project on clean engines, trying to solve the problems that I mentioned with the real driving. At the same time, all which is alternative fuels and alternative energies, except hydrogen, which is the JTI, is in the EGVI, Green Vehicles Initiative, so it's the follow-up of the Green Cars Initiative. And the focus will be really on application or getting stuff to the market and create jobs because of the crisis. That's a priority. This is a quite busy picture. It's just to give you an idea of what covers. So the white area is the core of the GVI. And you see that there are some areas which are in transition, which are the interfaces with the other domains. So for instance, chargers and the grid are in this area. Basically, we are looking more at the side of the car, but of course, whenever you have, and you must have interaction, there are projects possible there. For instance, we have projects in Green Cars initiative on inductive charging, for instance. We just, basically last week, closed the call of 2014. We covered 4 topics in electrification. For the first time, for instance, we covered the light vehicles, so L category, which before we only covered the L7. Now it's all down to the moped. And it had a huge success, I would say probably even too much, because as you can see, we had topics like batteries with 10 proposals, energy management 13, hybrids 7, and then 40 on the L vehicle. So there it was very difficult, very difficult evaluation. Nevertheless, I think the results will be announced in hopefully a few weeks. I think the coverage has been good, and I think we have really good projects selected. For the future, we have the call in 2015, which has a part, the first one which is in my domain, which is on conventional trucks, so not much probably interesting for you. While in DG Connect call, there is a topic which is quite interesting, I would say. It's actually 3 subtopics, which are together because they have interfaces. So we suggest that you address what is the main competence of your company or of your consortium, and if there are interfaces with the other domains, this is allowed and welcome. We don't think that a big proposal covering everything is good for many reasons. So on one end, you have a topic on vehicle architecture, particularly electric, let's say, architecture. It's looking at really something from a clean sheet of paper, what can be done to improve the efficiency, to improve the range, and so on. At the same time, there's the other topic, which is BMS, so it can be standalone or it can be joined partially with the other one. There it's really ICT and control technology. Of course, we start looking at standardization and things like that because we know that that's where cost savings can happen. And at the same time, test methodologies and modeling. And finally, the integration of the energy management at the whole level, including recharging and so on. So this is another area where ICT, for instance, the example I said from the French television, should be addressed with solutions which are coming in a topic like this. So this will be open next year. There's a lot of time to prepare. The impacts that we want is to try and advance the competitiveness of the vehicle as a whole, its performance, standard-based solutions, and so on. So that's my speech. I'm welcoming any questions if there is. Thank you.
You have any question? Please introduce yourself and ask the questions.
Hello, I'm Martin Messigi from University of Brussels. I don't have really a question, but I want to comment on the important issue that you raised with indeed LCA proving sometimes some reports that battery electric vehicles are not that interesting compared to conventional vehicles. Indeed, we did a big a literature study, around 70 papers that we reviewed, and indeed what we saw, like the point that you raised, that it is indeed with the, well, unrepresentativity of the NEDC cycle first, exactly. However, there are two other main aspects that I witnessed. And that's one, the selection of the vehicles that they choose. Mainly, they look at comparable vehicles. However, if you check the market, there is a large variability in the market. So that's why I try to promote more a range-based vehicle LCA approach. And secondly, it's of course based on the selection of electricity. Many papers are allocating 100% coal electricity to electric vehicles, and then proven that it's, well, the same or worse than conventional vehicles. For me, this is nothing saying about electric vehicle. This is just saying that coal electricity is a very bad idea for well, climate change.
Yeah, thank you. I share many of the points, and I would underline that, for instance, the picture I put on the sources of oil is for the same purpose, because the same way they use coal or dirty mix for electricity, then they should use also the same kind of mixes for oil. And if you do projections to the future, oil will get worse and worse, and electricity, at least in Europe, is supposed to be getting cleaner and cleaner. So there is also a kind of a possible crossing of the lines. But I would like really to know what is the starting point, because as I said, if you put the real emissions and everything, I would like to know what comes up. These papers are not making, or the ones I've seen at least, don't make any sensitivity analysis on this, and therefore, I don't know, simply. That's really a piece of curiosity, if you want, from my side.
I can show you. Okay, thanks.
I'm Rousseau, National Lab. Obviously, looking at electrified vehicles, standardization is very important, because this is what customers use to make purchase decisions. And you've shown at the beginning of the presentation that the difference between certification and real world is getting bigger and bigger over the past 5 years. So driving cycle, obviously one issue, but in the past 5 years, people have not drastically changed how they drive. So there are other issues behind that, right? Test procedure is one of them. In the US, road load coefficient, for example, are open. Everybody can look at them. In Europe, it's probably one of the most secretive numbers. So is the European Commission looking at test procedure and maybe have them a lot more open, to just try to decrease the difference between the standards and the real world?
Thank you. I'm speaking for the European Commission, but it's not my part of the European Commission doing this thing, so I cannot sign everything. What I know is that there are working groups on both the cycle and the procedure, that some of these flexibilities that I mentioned, which were found by a paper of TNO, and basically now more or less we have an idea of what they are. These are likely, will be likely reduced, because these were designed in a time where you had basically instrumentation and problems, but now you can be much more precise than that. So on one end, that's for sure going to improve. At the same time, as I mentioned, there is this class action. And what is interesting there is that they did the test with the procedure, and in some cases, even introducing some of the flexibilities. So they still found a difference, and therefore, we will see what happens, because frankly speaking, I knew about this TNO report and some of things like inflating the tires and so on, but apparently there is something that we will see what, if it gets to trial, first of all, and second, what they will find. About the openness and everything else, the point is that the Commission is giving the cycle and the procedure, but it is individual member states that do all the rest. So I cannot guarantee anything there, because in the end, once the procedure is out, the procedure doesn't say anything about that. How it actually happens, that's not in the hands of the Commission.
Thank you. Roche Ditrigui from IFSTAR, France. Thank you for your presentation. My question is about electricity production, because your strategy of the electric vehicles is quite impressive. But what about the link with the energy production in Europe and the future of this production?
As I said, this is, and also he said that this is one of the, let's say, variables that we have, but we have it for everything. Basically, energy is getting dirtier if it's fossil, and in Europe we have, there's been a decision which is to decouple the two things. Energy will be getting cleaner because there are other regulations on energy that are mandating that you have more renewables in place. And we see the results. In any case, this is, if you see the trends, some countries have greatly increased the renewable part. So basically, there is a mandate for everybody to do his own cleaning. There is also in the oil industry, there is a mandate to increase the efficiency, for instance. So the Commission is working in each dossier trying to improve that. And then, of course, when the two cross, like in this case, you will have the electric vehicle as efficient as possible, using the electricity as clean as possible. Over time, this should lead to the CO2 benefits that are expected. At the same time, it's clear that coal, just to make an example, is at the moment, and in some moment in the past was even more cheaper than oil and natural gas. You see in the US where natural gas has dropped dramatically, and then you see the response from the market immediately. So it's basically there's not a command and control system. The Commission doesn't work like that. It's giving guidelines and giving directions, and then the market and the actors adjust accordingly. But overall, the trend I see is that there is a cleaning of the electricity over time. The technologies which are, wind, solar, and so on, are improving as well, and therefore you will get in any case in that direction. That's what I don't find in these papers where we are using a bad mix and don't take into account these trends in both ways.
So thank you very much, Maurizio. Once again, I would like to thank the two speakers, Pedro Silva and Maurizio Maggiore. And just before closing the session, I will let Paolo, as General Chair, giving you some information about this day.
Thank you, Pedro and Maurizio and Christophe for this very interesting plenary session. Just to remember you that this afternoon we will have, besides the poster session, we will have at the same time a Portuguese Electric Vehicle Association session in English. The first one is in English to present the Portuguese case. So besides the infrastructure, also the communication between vehicles and charging, and also other things that are being done. And for tonight, the gala dinner will be at the Pavilhão Centro de Portugal. You have it on the map. You can go walking from the hotels. It's a very nice walking trip. So enjoy the rest of the day, and we see you around. Now we have the coffee break. Thank you very much.